In this video, we are going to solve definite integrals with products and powers of cotangent and cosecant. On this first slide, I have provided with you the four integral formulas that we already know. So if necessary, we may have to use those as we go through this process. So I just wanted to remind you those four formulas. Now, the strategy for integrating when we have a product of powers of cotangents and cosecants can be pretty complex. There are four main strategies that you see here. Basically, just remember, check what is the power on my cotangent. We've used a K to designate that. What is the power on my cosecant? We've used a J to designate that, and then find which strategy applies to your particular situation. So let's look at the example down at the bottom of the page. We have a cosecant to the fourth power. We have a cotangent to the second power. So they're both even. Our K is the cotangent power of 2. Our J is the cosecant power of 4. So if we want to see what strategy we could use, this first strategy is the one that I'm going to go with. J, remember our cosecant power is 4. It's even and it's greater than or equal to 2. So I'm going to pull out that first strategy and show you how we can use it for this problem. So there's our first strategy. So let's talk about it a little bit. We are going to take the original J power, we are going to reduce it by 2, and we're going to place 2 of them next to it so that we can then use the Pythagorean identity that the cosecant squared is equivalent to the cotangent squared plus 1. We're going to do that substitution, and then once we have got everything ready to go, we are going to use U substitution. We're going to let our U equal the cotangent of x, and du is equal to negative cosecant squared of x dx. So let's actually work it out for this particular problem. So we're going to take 2 of our cosecants. So remember, see how we split apart 2 of them. We are going to take 2 of them and rewrite it as cotangent squared plus 1. So you're going to see in parentheses our cotangent squared of x plus 1. And we're going to let u equal the cotangent of x. So you're going to see a u squared in this spot. You're going to see a u squared in that spot. We need to replace cosecant squared of x dx in our problem. So you'll notice that the derivative has a negative in front. So we do have to account for that. So let's do that substitution. When we do the substitution, I'm also going to substitute our boundaries of our integration with u's. I'm going to replace those x values with u's. If our x value is pi over 2, if we want to know what u is, just take the cotangent of pi over 2, which is 0. And then let's do it again for pi over 4. Our u would be the cotangent of pi over 4 or 1. So we get new boundaries. So I've replaced everything in my problem in terms of u. So we get the boundary. The pi over 4 became 1. The pi over 2 became 0. The negative is because of the fact that that derivative has a negative, and so we need to account for that. This was our u squared plus 1. This was our u squared. So we have everything we need. Let's make that look a little nicer. So you'll notice that I don't like the fact that these boundaries are not going in least to greatest order. So remember, we are allowed to turn the boundaries of our integration as long as we multiply through by -1. So technically, I just use that -1 here to turn those boundaries. And then I distributed our u to the 4th here and our u squared there. So now that's cleaned up, looks a little nicer. Let's use our antiderivative rules to take that integral. So when we do that, we get u to the 5th over 5 plus u to the 3rd over 3, and we are integrating from 0 to 1. So if we plug in 1, we get 1/5 plus 1/3. If we plug in 0, we get minus 0. So I didn't show you that, but that is why that happened. And if we combine those fractions, we get 8/15. Now let's do another one. If you take a look at this example, again, please let's look at what's our k and what's our j. Our cotangent is 1, our cosecant is 4 power. So our k is 1 and our j is 4. So if our k is odd and our j is greater than or equal to 1, we can use this strategy. And it says if j is even, we can use either the first or second strategy. But I wanted to show you a slightly different strategy. I wanted to show you strategy 2 here, just so you have one more to look at. So let's do this problem utilizing strategy number 2. So I've written that there so that you have it and we can refer to it. Let's take a look. So we've got this problem. We are integrating from pi over 4 to pi over 2. The quantity of the cosecant of x to the 4th power times the cotangent of x. So our k is 1, our j is 4. If we apply the formula to that, think about what we want to do. We want the power on the cotangent to go down by 1. We can't really do that because we could do, but the power on the cosecant goes down by 1, and that's why it became a 3. We're really just pulling out a cosecant and a cotangent to kind of be sitting next to the problem so that we can use this U substitution. So we're going to let u equal the cosecant. We're going to let du equal negative cosecant cotangent dx. So now let's take and do our substitution. Now I'm not only going to substitute everything that's inside our integration, but I am also going to substitute my boundaries just like I did on the last example. So if our upper boundary, we take the cosecant of pi over 2, we get 1. If we take the cosecant of pi over 4, we get square root of 2. So now let's do all of our substitutions. So I've substituted our boundaries. So we're going to go from pi over 2 to 1. And then we need that negative there because of the fact that the derivative of a cosecant is negative cosecant cotangent. So I put the negative in front of our substitution here for our cosecant, our u cubed. Now, again, just like before, our boundaries here need switched. That negative will allow us to do that very quickly. Otherwise, you end up with lots of negatives in the problem, and it makes it a little more difficult and easier to make a mistake. So let's switch those upper and lower bounds. And now we can just use our antiderivative rules. Our u to the 3rd is going to become a u to the 4th over 4. Our boundaries are, we're going to go from 1 to square root of 2. If you plug in square root of 2, you get 4 over 4. If you plug in 1, you get 1 over 4. So 4 over 4 minus 1 over 4. I just kept those common denominators because I knew it would be helpful to use it like that, even though 4 over 4 reduces. And we get an answer of 3/4. So that's a little bit about how we solve definite integrals with products and powers of cotangent and cosecant. I hope seeing those strategies help. Have a good day.